On this video, I will be explaining to you how to determine the molar mass of a given substance. The first thing you have to know about molar mass, I'm going to consider it with the letter with a big M, a capitalized M, is that it is going to be the mass of a substance. Little m is the mass over the amount of the substance you have. So amount. Oh, well, the unit for amount is the mole. I will be talking more about the mole in the next video on the stoichiometry and mole conversion, but you don't really have to know anything about the mole for now. I have to explain to you what molar mass is before getting into the mole, because it is really required for you to understand this concept. So, as you can imagine, the molar mass is going to be in grams over mole. And let's do a little practice for you to understand it better. This doesn't matter a lot for now. Okay, grams over moles. Now, the molar mass of an element by itself, like, let's say, oxygen. However, oxygen is diatomic, so in its elemental form, it has a 2 there. So it's going to be, so to get the molar mass of something, you will get the mass of it on the periodic table. So for oxygen, it says that it is 15.99. We're going to consider it 16 grams per mole. And you have to multiply that by the amount of times you have that element. Now, because oxygen is diatomic, in its elemental form, you have to multiply that by 2. So roughly the molar mass of oxygen in its diatomic form would be 32 grams per mole. Now, if you had something more like silver, which is a metal and has no diatomic form, the molar mass of silver would simply be its mass in the periodic table. So it would be 107.8 grams per mole. And well, because there's 1, you multiply that by 1, and it would be the same, 107.8 grams per mole. So, in an element, its molar mass is simply going to be its mass in the periodic table, except for the diatomic elements. If you don't know what a diatomic element, I recommend you to watch the previous video that I made on diatomic elements. Now let's do a little harder example. Let's try to get the molar mass of water. So we know that the molecule of water is composed of 2 hydrogens and 1 oxygen, so H2O. So in this case, you won't be able to just get the number from the periodic table. So what you have to do is you have to separate it into elements. So we have hydrogen here and we have oxygen here. And what you want to do is first write here the amount of times you have it. So you have hydrogen twice and you have oxygen once. And here you want to write its mass in the periodic table. So mass. The mass of hydrogen is roughly 1 and oxygen is about 16, and this is in grams per mole. Grams per mole. Well, to get the molar mass, you want to multiply this and this. So you will get here, separate it, 2 times 1 is 2, and 1 times 16 is 16. So you just add this up, you add it up, and you get 18 grams per mole, roughly. That is the molar mass of water. So the molar mass would be this. Now let's try one with 3 different elements. Now let's start something like 6 H6O3. So, like before, you want to separate it into the three different elements. See, it's carbon, hydrogen, and oxygen. Here you're gonna write amount. Let me fix this. So amount, mass, and then you can write molar mass here, big M. Separate it. And so we have 6 carbons, 6 hydrogens, and 3 oxygens. Then we have the mass of carbon is about 12.01. Hydrogen is roughly 1, you could say, and oxygen is 16. It is actually 15.99, but just to make it a little bit easier. And then you multiply these two, so 6 times 12, so it is 72.06. 6 times 1, 6, and 3 times 16, 48. Now we add these 3 molar masses up, and we get 126.06 grams per mole. And this is the molar mass of the whole molecule. So that is how you obtain the molar mass of an element or a molecule.